The first third of the 20th century was quite extraordinary, in that our picture of the fundamental nature of physical reality underwent two revolutions, and Albert Einstein was a key figure in both. One of these revolutions had to do with the very peculiar character of the smallest constituents of nature. At the beginning of the century, in order to explain the equilibrium states of matter and light, Max Planck proposed that energy could be transferred from one to the other only in little discrete bundles. No one seemed to appreciate the import of this until Einstein, 5 years later in 1905, realized that light, which had seemed to have been perfectly explained by Maxwell in the mid-19th century, as interweaving waves of electricity and magnetism, must now be simultaneously understood as made up, at its smallest scales, of little particles. Einstein's picture of light, regarded as mere fancy by most of his contemporaries, was strikingly confirmed by the initially skeptical American physicist Robert Millikan by 1916. This fundamental wave-particle paradox led eventually to the quantum revolution, finally formulated a decade or so later. Einstein is much better known, however, for his theory of relativity, which radically changed our view of space and time, and then gravitation. Actually, this revolution came in two distinct stages. In 1905, Einstein put forward his special theory, reconciling the seemingly impossible requirements of a finite speed of light, as demanded by Maxwell's observationally well-confirmed theory, and a requirement that uniform motion should not be detectable by local measurement. Others before Einstein had been working towards his 1905 resolution of this conundrum, and had already found many essential ingredients, but Einstein's point of view was more far-reaching, and had one particularly noteworthy conclusion: the equivalence of mass and energy, as embodied in his famous E=mc². In 1908 the Russian Hermann Minkowski reformulated these ideas as four-dimensional spacetime. Remarkable though special relativity was, it was the natural conclusion of many independent investigations, both theoretical and experimental. Einstein's 1915 general theory of relativity was, however, a bolt from the blue. Einstein had had the extraordinary insight that by bringing in gravity, the relativity principle could be extended from uniform motion to arbitrary acceleration, and Einstein saw that this led to a picture in which Minkowski's space-time must be curved. Most physicists and astronomers found this hard to take, and confirming observations remained sparse during Einstein's lifetime. Einstein's general relativity is now well tested, and even serves as an invaluable probe for ascertaining mass distributions in distant reaches of the universe. On the personal side, Einstein was effusive and enjoyed a joke. He loved music, playing the violin, and also sailing. He felt strongly about politics, espousing pacifist views. In his later years, he cared little about his appearance, though. Photographs of him in earlier years tell a different story. The world is enormously the richer for his having been here. Now let us meet him.